So in this lesson, I'm going to introduce you to data modeling in Quab. Data modeling is an experimental technology introduced in this product. So I describe it as experimental, but it's actually quite robust. Um, so you're looking at this project task management feature. Um, it has projects, it has groups, and then it has cards. The groups are basically these decks, and the deck can have any number of cards on it, as you can see. What's interesting is I'll show you the where this functionality is, the code base of this functionality. Um, so if we navigate under the to-do list, and you can do this in your own installation since the source code is all available in there. Um, what you would notice is so you have project, you have group, you have card. Those are the three models that make up this task management functionality. But what's interesting is there's actually no database table that represents project, group, or card. They're all mapped to the same database table. And I'll show you some examples of this. So here's a data statement that you use to add cards. Um, Notice here it says insert into card, but the interesting thing is when you go to the compile tab to see the actual SQL that will be executed, it says insert into pool underscore crud underscore data table underscore one. That's the actual database table that the model card is mapped to. Yet you're able to use the model card in your SQL as though it is an actual table. So let's come here and look at the data table for adding groups, that is groups of cards. Similarly, it says card group as the model, and you use that in your SQL just as you would use any database table in your SQL. Yet on the compile tab, it doesn't have that a card group there. Instead, it maps to the same database table as the card group. Similarly, if you look at the project, when you add a project, again in your SQL as a developer, you would use card project as your model because that's what you're modeling. But behind the scenes, Quab is able to convert it to an actual database table. Again, all three of these objects are using the same database table. There is no separate database table to represent them. So at the 50,000 foot level, that is what data modeling in Quab is about. It's about abstracting the database table and using it as a storage device instead of a modeling construct. The Quab environment provides a means for you to actually model your data, and the database table that you use is only for storage and not for actually modeling your data. Like I said, this is experimental, but it's actually quite robust because I'm already using it in this product, and it does have a few caveats that you have to think about, but you could actually use this in your own product where you think it may be well suited. If you've ever used, let's say if you've ever installed something like Drupal, Drupal has probably up to 100 database tables because it's a CMS that has to store everything that it has in a database table. Imagine instead of having 100 or close to 100 database tables, you could just create models that are mapped to the same database table and store your information in there. So that's an example of a use case that can really benefit from this type of technology. So in this lesson, I'm going to show you how to generate the database tables that we'll be using, and there are subsequent lessons where I'll give an example of actually doing data modeling in Quab. So let's generate a table, what we'll call, it's called DTCP table, that is database table and column pulling database tables. So it's if you look at the documentation, you will see references to DTCP technology. That's what I'm going to demo to you right now. So the first step is we'll go to our demo app that we created earlier in the previous lessons. It should have a data source already generated for us. So here's a default data source, and this point to the database, to the embedded database that was created for us. So we're going to use this to generate a DTCP table. The first step in creating a DTCP table is to create a category to hold all the information associated with generating that table. So let's create, let's say, let's call it DTCP table, right? So this is going to create that category. And the first step is, we're going to create a subcategory here called types. These types basically represent SQL types. That the whole idea is to generate a pool of columns of various SQL types. So basically what we're doing now is a generation strategy. So you could say, I want 10% of my tables to be varchar. I want another 10% to be integers. I want 5% to be some geometric type. Basically, whatever you think your database table, the type of data that you're going to be storing in your database tables, would determine what the nature of your generation strategy is. And I should add that this is completely optional. You could use any other tool to generate these tables. It's just the facility is provided in here for convenience, but you don't actually have to do the stuff that I'm showing you right now. So we've created a column, a category called types. So let's create some types that we're going to generate. As you can see, we're going to create a generated column type. Let's call this varchar. And we'll open this up, and you have to fill it in. We basically tell it that, okay, we want to generate varchar 256, and there are 10 columns of varchar that is going to be generated. Now we'll also generate a blob or a clob column, which is for storing large objects. Actually, you could basically just clone this. There's a functionality to clone, so instead of going through that whole stepping through the menu, you can just clone this. So we'll create a clone called blob, and we open it up. And replace it, say called blob. Right. We'll clone this again and create a new one called integer for integer types. All right. So we'll do this 3. Now we have our type. The types that we want to generate, there's 10 of each that's going to be generated. The next thing we want to do is we'll create a list, an instantiator list called types. And we'll open that up. And the way you create an instantiator list is to have entries that have no names. If you have entries that have no name, then it's assumed to be a list. Look at the documentation and you can see what that is. So we say, look under the category type or subfolder type, and it's a CRUD type. We'll make this final, and we want it to be evaluated. When it's evaluated, it means it will be invoked, and the result would then be included as part of the result of the types object. And I'll show you what that really looks like. So I'm using a virtual machine, which is a little bit slow for my Linux setup. That's why it seems to be complaining. Hopefully. All right, so let's do a refresh here and see. I don't know why it's oh crap. Somehow it somehow logged out. Looks like there may be some session management issue in the browser. I have other windows open, that might be why. Alright, so we'll go back to where we were before. Alright, so I didn't even add that. Anyway, let's say types. Say varchar .int. That means it's an instantiator, and we want it to be evaluated as a CRUD type. And you add it to the list. We add the second one, integer .int. Again, a CRUD type. And add it. And then we add the third one, which is the blob. So you put in the actual executable path, not the CRUD base path. So when you say types dash varchar, that's the relative URL relative to the types instantiator list that we're looking at, right? So the Quad platform knows how to resolve all of this URL at runtime when it's evaluating this type list. It would know that types dash blobs that int is an instantiator that is located relative to the types list, and it will invoke it and do the necessary processing. So we have that. Now we want to generate the actual strategy object. The way you create a strategy object is, again, and you say generated data table strategy, right? We select that and we just call that strategy. Again, like I said, this is all optional. It's sort of a nice to have utility for generating these types of DTCP tables. Think of the DTCP table as a big matrix, basically. So we have this, and it already fills in types for us, so we don't even have to type extra. We're going to use the data source in our application. You could use some other data source, but we'll use this data source. So drag this and drop it here, and it will put in the correct relative URL and everything for us. Sometimes you have to double check this. I believe there's a bug in there that we're trying to fix that can sometimes give the wrong relative URL. Optionally, you could create your own data table, your own data statement to actually execute the results in SQL, but we don't need to do that, so we'll just ignore this second parameter here. So you do save. Again, there's detailed documentation on some of this stuff if you can't quite follow this one. So we've created a strategy, and we need to make this client-side executable, because we're going to invoke it from the client. So there's a utility for generating the DTCP tables. From the application menu, you go to data modeling, you click generate, and it gives you this view. So now we're going to take this strategy that we just created and drop it here. Notice the strategy has the data source against which things would be executed, and it has the types list, which says the list of types to generate and the number of them to generate. So we're going to click generate, and notice how it created the pool database table and column for us. So we see how, here you have pool column number 1 up to the 10, and then at 11 it has integers, and then at 21 it has blobs. So that's the basic idea. It's just a utility to generate this type of tables for you. This is not something that you're going to be doing regularly. Per application you might do this once, so it's not really a big deal. Yeah, so let's call this DTCP table, and now you can actually execute this from here. So let's open up the log just to see if there's a make sure there's no error in there once we run it. So now let's say create, and what it's going to do, the data source that we specified, it's going to run a create statement against that data source to create the data, this DTCP table that was just generated. So there's no error, which means our table was created. So that's the first step in data modeling in Quab. The next lesson will show you how to generate what's called a data table object, which is basically just an object that represents the DTCP table that we created, except it's an abstraction of this table, right? So the data table is going to be an abstraction of this database table here that you're looking at. So instead of using this database table within our application, we'll be using the data table object within Quab. The data table object is a Quab object. So the next lesson would cover how to create that and generate it. Thank you.